The fuel injection pump is one of the most critical components in heavy-duty diesel engines, especially in models such as Stralis, Trakker, and Holland T9. This component, identifiable by multiple part numbers including 0445020195, 0986437512, 5,801,486,599, and 504,388,756, performs the essential task of delivering fuel under precise pressure and timing to ensure efficient combustion and engine reliability. Exploring this component's design, function, inspection points, installation, and operational testing is vital for anyone involved in heavy vehicle maintenance or repairs. The main function of the fuel injection pump is to pressurize diesel fuel and deliver it to the injectors in a controlled manner. This process must be perfectly timed and calibrated to match the engine's combustion cycle. Any variation in timing or pressure can cause suboptimal combustion, resulting in decreased engine performance, higher emissions, fuel wastage, or even damage to engine internals. For heavy-duty trucks working in challenging environments and long-distance hauling, the reliability and precision of the pump can't be overstated. These specific pump part numbers, 0445020195, 0986437512, 5,801,486,599, 504,388,756, are often used interchangeably or referenced across different markets, but each one corresponds to specific configuration suitable for the Stralis, Trakker, and Holland T9 engine variants. This multiple compatibility means easier sourcing of spares and better serviceability in regions worldwide. Upon receiving this pump, the first action should always be a thorough inspection before installation. Visually check the external surfaces of the pump for any signs of defects, including casting irregularities, rough edges, or damage to the mounting flanges and ports. It's critical that the inlet and outlet ports, as well as the bolt holes, align perfectly with the engine's configuration. Misalignment or burrs can cause fuel leaks or installation difficulties. Next, when possible, an internal inspection should be conducted. This involves examining the rotor, plungers, sleeves, seals, and internal bore surfaces for any signs of wear, corrosion, scoring, or pitting. These internal components are machined to very tight tolerances to ensure correct fuel metering and pressure generation. Even minor imperfections can result in decreased pump efficiency or premature failure. Calibration is a decisive step in the pump's effectiveness. Some pumps are delivered factory calibrated, whereas others require adjustment at specialized workshops equipped with calibration benches. Calibration ensures the pump delivers fuel at the correct pressure and timing profiles matching the engine specifications. Incorrect calibration may cause issues such as engine knocking, black smoke emissions, or reduced power output. The physical mounting and connection points are equally important. All the fuel feed, return lines, and mounting flanges must match the engine design. Using adapters or modifications can jeopardize the system's integrity, introducing leaks or dead volume areas that disrupt fuel flow and pressure consistency. After installation, the system must be primed properly to remove air pockets. The pump should be bench tested if possible, with pressure gauges monitoring output at various engine operating points. During the first runs, close observation for any leaks, pressure drops, or unusual exhaust smoke is essential to catch any early faults. Choosing this pump over others can be based on factors like OEM quality, multi-market compatibility, and cost-effectiveness. Pumps with these